Welcome to Math Contest Drills for Filipino Kids. Let us have the solution to MMC 2019 Elimination Round, Grade 9, Part 2. Let us recall the instruction. Give all fractions and ratios in lowest terms. All denominators should be rationalized. Figures are not drawn to scale. Number 26. Let A, B, and C be positive quantities such that A varies directly as B and inversely as C. If C increases and B decreases, will A increase or decrease? Let us have the model of variation. We have A is equal to KB over C, where K is the constant of variation. Since A is directly proportional to B, then as B decreases, A also decreases. Also, since A is inversely proportional to C, then as C increases, the value of A decreases. Hence, A will decrease. Next number. It takes 10 hours for 6 painters to paint a house. How many hours would it take 15 painters? This is an example of an inverse proportion. So we have P sub 1 over P sub 2 equals T sub 2 over T sub 1, where P is the number of painters and T is the time. Solving for T sub 2, we have T sub 1 times P sub 1 over P sub 2. Then let us substitute the values. T sub 1 is 10, P sub 1 is 6, and P sub 2 is 15. So T sub 2 is equal to 10 times 6 over 15. That is 60 over 15. Then it would take 4 hours. Next number. The sides of a triangle are in the ratio 3 to 4 to 6. Find the longest side in centimeters if its perimeter is 52 centimeters. Let x be the scale factor, so we will have the equation 3x plus 4x plus 6x, the sum of the length of the sides of the triangle, equals 52. So we have 13x equals 52, therefore x equals 4. Therefore, the longest side is 6 times 4, 24 centimeters. 29. The angles of a quadrilateral are in the ratio 2 to 3 to 3 to 4. Find its smallest angle. Let us use x as the scale factor as we did in the previous item. We know that the sum of the interior angles of a quadrilateral is 360 degrees. Therefore, we have 2x plus 3x plus 3x plus 4x equals 360. Then we have 12x equals 360. Divide both sides by 12. We will have x is equal to 30. Hence, the smallest angle is 2 times 30. That is 60 degrees. Next number. If quantity x plus y is to y equals 17 is to 6, find quantity x minus y is to y. Let us have the proportion. We know that the cross product property of proportion, we have the product of the extremes equals the product of the means. Hence, we have 6 times x plus y, 6x plus 6y equals y times 17, 17y. Subtract 6y from both sides, we will have 6x equals 11y. Rewriting the proportion, we will have x over y equals 11 over 6. Now, if we subtract 1 from both sides of the equality, we will have x over y minus 1 equals 11 over 6 minus 1. Rewriting the left-hand side as a single fraction, we have x minus y over y equals 5:6. And written as a proportion, this will be x minus y to y equals 5:6. Therefore, the answer is 5:6. Number 31. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4, and 5 if the digits are unique? If the digits are unique, therefore, repetitions are not allowed. So let us have the 3 numbers, or the 3-digit numbers. In the first digit, we have 5 choices. That's 1, 2, 3, 4, and 5. If we have used one of the 5 digits, we cannot use it anymore in the second digit. So we will only have 4 choices in the second digit. Again, if we have used 2 of the digits already, we cannot use them again. So we will only have 3 choices for the third digit. By multiplication principle, we multiply this 5 times 4 times 3. That will be 60 3-digit numbers that can be formed. Next, a class has 20 girls and 30 boys. Half of the girls and a third of the boys wear eyeglasses. If a student is picked at random from this class, what is the probability of this student wearing eyeglasses? So let E be the event that a student picked at random wears eyeglasses. So P of E is equal to 20 times 1/2, that is half of the girls, plus 30 times 1/3, that is third of the boys, all over 50, that is the total number of students in the class. So we have the probability of the event is equal to 20 over 50 equals 2/5 or 0.4, or we say 40%. Next, number 33. The 3 sides of a triangle have integer lengths. If 2 sides have lengths 4 and 9, what is the least possible length of the third side? In here, we're going to use the triangle inequality, where the third side is greater than the difference of the lengths of the 2 sides, but less than the sum of the lengths of the 2 given sides. So x is greater than 9 minus 4, but less than 9 plus 4. So the third side can only be a value that is greater than 5 but less than 13. Therefore, the least possible length of the third side is 6 units. Next number. In triangle ABC, angle A is 71 degrees and angle C is 67 degrees. Which of the 3 sides is the shortest? If angle A is equal to 71 and angle C is equal to 67, then the measure of angle B in the triangle is 180 minus the sum of the measures of angle A and C. That will be 180 minus 71 plus 67. Therefore, the measure of angle B is 42 degrees. Hence, the angles of triangle ABC in increasing order: angle B, angle C, and angle A. The shortest side of the triangle is opposite the smallest angle. Therefore, the shortest side is opposite angle B, that is side AC. Next, number 35. In the figure, angle ADB equals 120 degrees, angle CDB equals 140 degrees, AD equals CD. If AB is equal to 3x minus 6 and CB equals 24, what are the possible values of x? By hinge theorem, since angle BDC is greater than angle BDA, then CB is greater than AB. So 24 is greater than 3x minus 6. Add 6 to both sides. 30 is greater than 3x. Divide both sides by 3. Then x is less than 10. However, a side of the triangle cannot be 0. Therefore, x is greater than 2 but less than 10. For problems numbers 36 to 41, use the figure. The four segments marked with arrowheads are parallel. The problems are related to it but do not depend on each other. Number 36. If angle AGF is equal to 3x degrees, angle GFH is equal to 48 degrees, and angle FEC is equal to 2x plus 4y degrees, find the value of y. The measure of angle AGF is equal to the measure of angle GFH. Since AGF and GFH are alternate interior angles, therefore we have 3x is equal to 48 and x is equal to 16. Angle GFH and angle FEC are supplementary. Angle GFH is vertical with angle BFE, while angle BFE and angle FEC are same side interior angles. Therefore, the two angles are supplementary. Hence, we have 48 plus 2x plus 4y equals 180. X is 16, so we have 48 plus 2 times 16 plus 4y equals 180. 4y is equal to 180 minus 48 minus 32. That is from 2 times 16. Then 4y is equal to 100. Divide both sides by 4. We'll have y is equal to 25. Next, if AB equals 5, BC equals 6, and CD equals 4, GJ is equal to 21, find HJ. By proportional segments theorem, we can have the proportion AD is to BD equals GJ is to HJ. Solving for HJ, we have BD times GJ, that's the product of the means, over AD. But BD is equal to BC plus CD. BC and CD are given, so we have BD is equal to 6 plus 4, that is equal to 10. GJ is given as 21. AD is equal to AB plus BC plus CD. AB, BC, and CD are given, so we have AD is equal to 15. Now we can solve for HJ, substituting the values. 10 times 21 over 15, and that is equal to 14. Next, number 38. If GH is equal to 3, HI is equal to 5, HF is equal to 2.25, find IE. From the figure, we can see that triangle GHF and triangle GIE have common angles G, and since HF is parallel to IE, we have angle GHF congruent to angle GIE. Therefore, by AA similarity theorem, triangle GHF is similar to triangle GIE. And from that similarity, we can form the proportion GH over GI is equal to HF over IE. Solving for IE, we have GI times HF over GH. Substitute the values. 8 times 2.25 divided by 3. Then IE is equal to 6. Next number. If GH is equal to 15, HI is equal to 25, IJ equals Y, AB equals X, BC equals 20, and CD equals 8, find X plus Y. From the proportional segments theorem, we have GH to HI equals AB to BC. Substituting the values, we have 15 to 25 equals X to 20. Therefore, X is equal to 15 times 20 over 25, and X is equal to 12. Also, we have HI to IJ equals BC to CD. Then, substituting the values, we have 25 to Y equals 20 to 8. Hence, Y equals 25 times 8 over 20, and Y is equal to 10. X plus Y, therefore, is equal to 12 plus 10, 22. Next, number 40. If AB equals 2x minus 3, BC equals 2x plus 7, GF is equal to 3x minus 3, and FE equals 3x plus 13, find X. From the proportional segments theorem, we have AB over BC equals GF over FE. Substituting the values, we have 2x minus 3 over 2x plus 7 equals 3x minus 3 over 3x plus 13. Multiplying both sides by the product 2x plus 7 times 3x plus 13 yields 6x squared plus 17x minus 39 equals 6x squared plus 15x minus 21. Combining similar terms, we get 2x equals 18. Therefore, x is equal to 9. Next, number 41. Suppose I is the midpoint of HJ. If HF equals 3x, IE equals 5x, and JD equals 5x plus 12, find x. If I is the midpoint of HJ and HF is parallel to IE, parallel to JD, then IE is the mid-segment of trapezoid FHJD. Relating the mid-segment of the trapezoid to the two parallel sides, then we have IE is equal to 1/2 times the sum of the lengths of the parallel sides of the trapezoid, HF plus JD. Substituting the values, we have 5x equals 1/2 times the quantity 3x plus 5x plus 12. Multiplying all terms by 2 and combining similar terms in the parentheses, we have 5x times 2, that is 10x, and then on the right hand side we have 8x plus 12. Therefore, 2x equals 12 and x is equal to 6. Next number. The diagonals of a parallelogram ABCD meet at P if PA equals x squared, PC is equal to x plus 6, and PD is equal to 2x minus 1. Find PB. The diagonals of a parallelogram bisect each other. Therefore, PA is equal to PC. These are the segments of the diagonal AC. Substituting the values, x squared equals x plus 6. Then this is a quadratic equation. We write in general form x squared minus x minus 6 equals 0. Extract the roots by factoring. We will get x minus 3 times the quantity x plus 2 equals 0. Getting the roots by equating each factor to 0, we have x equals 3 and x equals negative 2. However, we do not accept x equals negative 2 because it will yield a negative value at some dimensions. Therefore, PD is equal to 2 times 3 minus 1. PD is equal to 5. Since PD is equal to PB, these are the segments of diagonal DB, PB is also equal to 5. Next number. The diagonals of a rhombus have lengths 10 and 14. What is the perimeter? The diagonals of a rhombus bisect each other and are perpendicular. The side of the rhombus, therefore, is the square root of 5 squared plus 7 squared, where 5 is half of the 10 unit diagonal and 7 is half of the 14 unit diagonal. Therefore, the side of the rhombus is the square root of 74. To find the perimeter of the rhombus, we multiply the length of the side by 4. Therefore, the perimeter is 4 times the square root of 74 units. Next, number 44. Two similar triangles have perimeters 16 and 18. Find the ratio of their areas. If two similar triangles have perimeters in the ratio A to B, then their areas have the ratio A squared to B squared. Therefore, the ratio of the sides of the similar triangles is 16 to 18, simplified as 8 to 9. Then the ratio of the areas will be 64 to 81. Next, number 45. The sides of a right triangle have lengths x minus 2, 2x, and 2x plus 2. Find its area. From the given lengths, 2x plus 2 is the largest, therefore it must be the hypotenuse of the right triangle. Therefore, we have the equation square of the hypotenuse equals the sum of the squares of the legs. 2x plus 2 squared equals 2x squared plus x minus 2 squared. On the left hand side, we have 4x squared plus 8x plus 4. On the right hand side, we have 4x squared plus the square of x minus 2, x squared minus 4x plus 4. Simplifying this equation, we will have x squared minus 12x equals 0. Canceling 4x squared and 4. So what is left is x squared minus 12x equals 0. By factoring, we have x times the quantity x minus 12 equals 0. Get x equals 12 for the value of x. Since 0 cannot be a value, it will make the side 2x as equal to 0. Hence, the legs of the right triangle measure 10 and 24. 10 is from 12 minus 2 and 24 is from 2 times 12. Therefore, the area of the right triangle is equal to 10 times 24 divided by 2. Since the legs are perpendicular to each other, we can consider this as the base and the height of the triangle. The area is 120 square units. In a right triangle, the altitude to the hypotenuse divides the hypotenuse into segments with lengths 5 and 20. Find the length of this altitude. In right triangle similarity theorem, we have the relationship between the altitude of the right triangle and the segments for which the hypotenuse was divided. Let h be the altitude of the right triangle. H is the geometric mean between the segments of the hypotenuse 5 and 20. H is equal to the square root of 5 times 20. Then H is equal to the square root of 100. The altitude therefore is equal to 10 units. Next, the sides of a triangle have length 7, 11, and 16. Find the perimeter of a similar triangle whose longest side is 24. Let A and B be the other two sides of the other triangle. Then A to 7 equals B to 11 equals 24 to 16. Solving for A, that will be 24 times 7 over 16. A is 10.5. Solving for B, that is 24 times 11 over 16. That is 16.5. Therefore, the perimeter of the larger triangle is 10.5 plus 16.5 plus 24, 51 units. Next number. In triangle ABC, D is chosen on AB and E is chosen on AC, such that angle AED is equal to angle B. If AE equals 9, EC equals 3, DE equals 7, and AD equals 8, find BD. Let us have the figure for this problem. From the figure, we can prove that triangle ABC is similar to triangle AED because the two triangles have a common angle A. Also, it is given that angle AED is congruent or equal to angle B. Hence, by AA similarity theorem, triangle ABC is similar to triangle AED. And from this similarity, we can form the proportion AB over AC equals AE over AD. AB is 8 plus BD, AC is 9 plus 3, AE equals 9, and AD equals 8. Then we have 8 times 8 plus BD, 64 plus 8 BD. 9 plus 3 is 12 times 9, that is 108. Therefore, 8BD is equal to 108 minus 64. Divide both sides by 8. We have BD equals 5.5 units. Next number. An equilateral triangle and a square have same perimeter. Find the area of the triangle if the square has area 36. If the area of the square is 36, then each side is 6 units, and the perimeter is 6 times 4, 24. Also, the perimeter of the triangle is 24 because it is given that the equilateral triangle and the square have the same perimeter. If the perimeter of the triangle is 24, then each side is 8 units. Given an equilateral triangle, the area is S squared times the square root of 3 over 4. S is equal to 8, therefore the area is 8 squared, the square root of 3 over 4. That is 64 square root of 3 over 4. Therefore, the area of the equilateral triangle is 16 square root of 3 square units. Last number. In isosceles trapezoid STAY with parallel sides ST and AY, ST equals 3m minus 7n, SA equals 3m minus 2n, TY equals 2m plus 3n, and AY is equal to 3m plus 7n. Find m over n. If we have an isosceles trapezoid, then the diagonals are congruent. So we have SA is equal to TY. Substituting the values, SA is 3m minus 2n, TY is 2m plus 3n. Subtracting 2m from both sides, also adding 2n to both sides, we have 3m minus 2m equals 2n plus 3n, then m equals 5n. Dividing both sides by n, we have m over n equals 5. That is all. Thank you for watching. Part 1 was uploaded prior to this video. Please subscribe for more math contest drills for Filipino kids videos.